This podcast will go over the configuration required for the Router Basics Lab. Each student will have two PCs, a switch, and a router. They will configure on their own, and then they will connect to their neighbor's router to test connectivity across the two routers. I am not going to configure both sides. I will only configure the one side. Configuration of the other side will be the same, with the exception of you will have different IP addresses. So I've already connected my PCs to my switch and my two router interfaces to my switch. In this case, each PC will be in a different VLAN on the switch. Putting the PCs in the VLANs and assigning IP addresses on the PCs are things we've already done. I'll do them again quickly, but you should already know how to do those things. I'm going to start out with the PCs. One of my subnets will be the 0 subnet. So I'm going to make my PC 192.168.0.2 the subnet mask of a 24-bit subnet mask, and my gateway is going to be 0.1. This is the IP address I will be configuring on the router once I get to the router. My other PC is PC1, so that will make the IP address need to be 192.168.1.2 with a 24-bit subnet mask, and the gateway should be 192.168.1.1. I'm going to use VLAN 10 and VLAN 20 on my switch. So I need to go into the switch and configure the VLANs. We did this in previous labs, so I'm not going to talk while I do it. I'm just going to do it. Alright, so at this point I have put the interface switch ports for this PC and this router interface in VLAN 10, and this PC and this router interface in VLAN 20. Now I need to perform the configuration of the router. If you notice, it says continue with configuration dialog. We always want to answer no to that in our classes because that's going to ask you some questions which will configure things for you, and we would much rather configure things ourselves than have the wizard to do it for us because we need to learn the commands. So the lab sheet says you configure the host name. So to be in configuration, you need to type enable and then conf t, configure terminal, whatever you like to type for that. First thing we want to set is the host name. I'm going to name my router 0. Then it says to set some passwords. We're going to set the enable password using the enable secret command, and we're going to set it to class. There's also an enable password command, and I'll use it as well just to demonstrate something to you in a few minutes. Enable password CNT. The other passwords we want to set a console password. So to get into the configuration mode, to set the console password, the command is line console 0. Once you're in there, two commands we want to do. We're going to type the login command, which enables the login process, and then we want to set the password, and we'll set that password to secret. Right, we also want to configure telnet. Telnet is accomplished on the VTY line 0 to 15. We'll do telnet because configuring SSH requires some extra configuration that we're not going to do at this point. So first you put line VTY 0, 15 because there's 16 virtual terminal lines, and then you type the same commands, login, and then the password you want it to be, we'll use CNT again. So that's the password configuration. The thing I wanted to show you was in the configuration, the enable secret command and the enable password command both showed up. The difference is the enable secret command, the password is encrypted. I can't see what that password is. It's actually hashed. The enable password command is in clear text. If both of these commands are in the configuration, only the secret command will be honored. You will not be able to get enable mode using this enable password if the enable secret command is also in the configuration. So that was the interesting thing I wanted to tell you about that. If we scroll down here to the end, you can see line console 0, password, secret, and login. And then the VTY lines get separated into two different entries, and that's just a legacy issue from when routers only supported 4 VTY lines, or 5 VTY lines, 0 to 4. So now that the passwords are configured, the next thing I want to configure are some interfaces. I'll type interface, fast Ethernet, 0/0. This is my interface that it is in VLAN 10, so I need to set the IP address appropriately for that VLAN. And the VLAN I use on the IP scheme I used on that VLAN was to make it the 0 subnet and .1 with a 24-bit mask. You need to know shutdown. Next, I want to configure fast Ethernet 0/1. I'm using the up arrow to scroll back through my commands if you're not familiar with that. Then I'm going to make it 1.1. I need to do a no shutdown on that interface as well. So at this point, I've configured the host names and passwords and the fast Ethernet interfaces. So I should be able to ping from PC to PC. Okay, that didn't work. You may experience something similar to that, so that's a good troubleshooting opportunity for us. What's the first thing I'm going to look at? First thing I'm going to look at is I'm going to run the command on my router, show IP interface brief. I'm going to abbreviate it. This will show me my IP addresses and whether my interfaces are up and up. So they're both up and up. So my interfaces are good on my router. Next thing I'm going to want to do is try to ping my router interface from this PC. Okay, I can ping my router from this side. Now I want to try to ping my router from this side. And that worked. So there's no reason that that ping should not work unless I'm missing my gateway settings on one of my PCs or have an error in my gateway setting on one of my PCs. And I do not. Okay, so it works now. Sometimes the simulator can be a little temperamental, but that was good because I was able to show you some things you could check if yours is not working. If when I was on PC 0 and I tried to ping the router interface, if it did not work, then I would want to check my switch ports to make sure they're in the correct VLANs. Okay, the final interface we want to configure, we're going to use a serial interface to connect to our neighbor's router. So we want to configure that serial interface. In our routers in the lab, the serial interfaces are serial 0, 1, and then either 0 or 1, depending on which port you plugged into. If you plugged into the bottom port on the serial card, it'll be 0. If you plugged into the top port, it'll be 1. I plugged in the bottom port, so I will be using 0. I'm going to give it an IP address. I'm going to give it this IP to match what I did on the other side because I already configured the IP on the other side serial so that it would come up, hopefully. Okay, so my interfaces are up and up. Another command that might be helpful for you to know and use sometime is show IP route. We'll look at our routing table. As you can see, I have connected routes in those 3 networks for what I have configured. So the final step in our configuration to make things work is we need to add a route between the router on one side to the router on the other side. We could configure RIP, and we're going to do that in a little while. But first thing we're going to do is configure a static default route. A default route on your PC tells your PC what to do with packets it does not know what to do with, and a router needs the same thing. So on our router, we're going to enter a static default route with the command IP route. And the syntax we're going to use for that is we're going to put all zeros for the network address. We're going to put all zeros for the subnet mask, and then we're going to put the IP address of the next hop, which in this case, the next hop is going to be the other router. So I'm telling my router, anything you do not know what to do with, send to that other router. Now if I look at my routing table, you see I have a gateway of last resort set as well. So now my router knows anything you do not know what to do with, send to that other router. The next thing we're going to do is we're going to get rid of that route we just added. In the real world, you probably never get rid of your default route because you always want to have a default route. To get rid of that default route, we're going to put no in front of the command we used to enter it. So with Cisco, most of the time, to get rid of a command you put in, you need to do no in front of it. Let's go back for a second. Pretend you messed up your default route and put the wrong thing, right? So you put say 2 was incorrect. I meant to put 3. Once I put 3 in, a lot of people think, oh, hey, that's going to overwrite. Well, if you look at the config, that did not overwrite the other command. If you want to get rid of it, you need to put no in front of it to get rid of it. So at this point, I'm going to take both of those routes out. Now if I look at my config, I no longer have the default route in there. Now I'm going to configure RIP version 2. To configure RIP version 2, you get in config mode and type router RIP version 2, and then you need to provide a list of the networks that you are connected to. You don't need to provide a list of all the networks in the internetwork, just the ones your router is connected to. So if we look at my interfaces, I am connected to the 0 network, the 1 network, and the 10 network. So my networks for my router RIP configuration will be 192.168.0.0, 192.168.1.0, and 192.168.10.0. And that takes care of the router configuration. If I had the other router configured, I could do show IP route, and it would show the routes it learned from the other router. There would be a R on this side. You guys will look at that in the lab. I don't have the other router configured, so we're not going to see that at this point. If you don't have any R's in here when you're expecting RIP to work, then that means somebody didn't do something right. The other configuration we need to do on this lab is to change the MTU setting on the serial interface. We're going to force some fragmentation so we can look at some fragmented packets to understand how fragmentation works. So to configure the MTU on the serial interface, we simply go into the serial interface and type MTU 700, for example, if you wanted to set the MTU to 700. And it says, oh, hey, it may not work with IPv6. Well, that's fine. We're not doing IPv6. So that concludes the basic configuration required for the router basics lab.